So today we will learn the basic concept of resistance, inductance, capacitance in AC analysis. So what is given? Voltage, that is the instantaneous voltage, is written as 20 cos 1000 t plus 30 degree. How we write? V is equal to Vm cos omega t plus theta. So this is the expression of the sinusoidal voltage. So Vm is equal to 20. And this is omega is equal to 1000 and this theta is 30 degree. That is omega is equal to 1000 radian per second. I can write this voltage in polar form. V is equal to 20 angle 30. And what is given? There is circuit. In one circuit, number 1, it is given that one resistance of 4 kilo ohms and it is connected across this voltage. Voltage is applied 20 angle 30 degree to this circuits. So we have to find out the steady state current. So this current, steady state current means the RMS value. This is equal to V by the impedance of resistance. Here I will tell you, if the element is resistance, then its impedance is R. And admittance just is equal to 1 upon R. It is denoted as G. Now, if the element is inductance, then its impedance is J omega L. And its admittance is 1 upon J omega L. If the element is capacitance, its impedance is 1 upon J omega C. So its admittance is J omega C. We have to remember all these things. Now the current is equal to V by ZR and it is given this 4 kilo ohms. So this is equal to 20 angle of 30 degree divided by 4000. So I can write 20 angle of 30 degree into 10 to the power minus 3 divided by 4. So this is equal to how much? 5. 10 to the power minus 2 is milli. 5 angle 30 degree milli ampere. Now what will be the instantaneous current? If the resistance 4 kilo ohms is connected, then I is equal to 5 cos of 1000 t plus 30 degree milliampere. What I can see, if the voltage equation is 20 cos 1000 t plus 30 degree, current equation is the same thing, only this magnitude changes. So if it is current, then voltage in the same line, same. Voltage and current are in the same phasor. Now, in number 2, what is that? It is connected to 20 millihenry pure inductor. So number 2, this is connected to pure inductor. This is V angle, sorry, this is 20 angle of 30 degree, and this is inductance is 20 millihenry. L is equal to 20 millihenry. Then what will be the ZL? ZL is equal to J omega L. So J omega L. So this is J. Omega means into 1000 into L means 20 millihenry. So 20 into 10 to the power minus 3. This unit is ohm. So this is 1000, this is 20, this is 10 to the power minus 3. So we have J20 ohm. Here we are using J operator. J means, I am explaining these portions. If you draw two perpendicular lines, say this is X dash Y dash. So if you move 90 degree from X to Y axis, this is J axis. Then again you multiply this J with another J, here it will be J square. And we know J is equal to under root minus 1. So J square is equal to minus 1. So here it is minus 1. Now you multiply J square with another J. So this is J cube. Here it is minus 1 into J. So this is equal to, in this direction, it is minus J. Here it is plus J, this is minus J. Now if you again you multiply J cube into J, this is J to the power 4. That is J square into J square. That is minus 1 into minus 1 plus 1. So this is, here it is plus 1. So whenever there is inductor, so it is plus J omega L. So now the ZL is equal to J20 ohms. So the current I is equal to V by ZL. So this is equal to 20 angle 30. Here I can write J20. Now J20 is equal to 20 angle 90 degree. So I can write 20 angle 30 degree divided by 20 angle plus 90 degree. 20 cancel, this is 1, and 30 minus 60, so angle minus 60 degree. Here the basic concept is, if the voltage is applied to any inductive circuits, voltage will lead, current will lag. So here we can see current is lagging by 60 degree. So instantaneous current I is equal to, magnitude of the current is 1. So this is 1 cos 1000 t minus 60 degree. So what I told, in case of pure inductor, current lags. This ampere. Now in the third case, one capacitor is there, and the magnitude of the capacitor is 10 microfarad, and we are applying an AC voltage. This is 20 angle 30 degree. So what will be the impedance? ZC is equal to, I have written over here, ZC is equal to 1 upon j omega c. So I can write ZC is equal to 1 upon j omega c. So I am multiplying numerator and denominator by j. So this will be j, and the denominator is j square omega c. So this is j square means minus 1. So it is minus j by omega c. So this is equal to minus j by omega means 1000, and c is equal to 10 microfarad. So 10 into 10 to the power minus 6. So here it is 1, 2, 3, 4 at 10 to the minus 6. So it will be minus j 100 ohm. So ZC is equal to, impedance of the capacitor is equal to minus j 100 ohms. So I is equal to V by ZC. So this is V is equal to 20 angle 30 degree divided by minus j 100. So what is it? Minus j. Minus j means here. So minus 90 degree, right? This is plus 90 degree. This is minus 90 degree. So directly I can write it 20 angle 30 degree divided by 100 angle of minus 90 degree. So 20 by 100, that is equal to 0.2, and minus 30, the 30 minus minus 90. So the angle will be plus 120 degree. So in case of capacitor, current leads by plus 120 degree. So instantaneous current I is equal to 0.2 cos of 1000 t plus 120 degree. So in case of capacitor, current leads. Here the current leads voltage. And in case of inductor, what we have seen? Voltage leads. Okay? And in case of resistance, voltage and current, both are same phase. So angle between voltage and current is equal to 0. So this way we can solve AC problem. These are the fundamental concepts. So for the exams to try to clear your doubts. So if you have any doubts, you can write in the comments line. Thank you very much for watching.